Yes, my friend. Welcome to this video. In this video, we will see how we can use code to implement the points on the elliptic curve. Actually, we don't pay too much attention to the curve itself, but we are very interested in those points on the curve. And if we can define the operation on all the points of the elliptic curve, we can make all those points on the elliptic curve to be a finite field. Then we will see this in the later video. Now in this video, let's see how we can use code to implement the points on the curve, on the given curve. So here, let's add another file here. We can set its point dot go here. And here we need to first bring the import and the packet into the file. So we copy this and paste it here. Okay, so let's first define the define the point itself. So we have time point struct. Now here we have the we need to put the efficiency of the equation here. Equation of the curve. We need to put the four coefficients of curve here. So we have A is a big the in no it here. B is still the big in, and so X and Y should be the value, should be the point on the curve. So we put X here, let's do the big and in, and Y is to the big and in. And here, so here we need to define some operation on the bit value. So here we need to define let's define type here, op type. The op type is actually it's just a in type. So we need a constant here. So that so we said it's op type and IOTA. Actually, this means the immune on the Golang. So let's go on sub val diff is exponential. So if you are not familiar with the Golang, this is only define the emulation constant on these values. For example, if you are familiar with the JavaScript or C++, and this is only the constant here, that at 0 and constant, and this one, this one, the sub is 1, etc. It's just a kind of emulation here. So this is 0, this is 1, and this is 2, this is 3, this is 4. So it's just a kind of emulation here. So it's a kind of email type in Golang. And this is for those friends that are not familiar with Golang. So let's keep going on. Now we need to define the operation we need to define the operation on the bit value here. So we have a function here. We say op on bit. Here we have x here and bit in and y here and still the bit in here. And here we have op type here. So we decide op type here and we return the bit in here. Okay. So let's define the op here, op and in here. Now we check the op type. We check the type here. Right, we check the type here. And for each case, if it's add, so we return the add here. Okay, we return the add here. If it's the sub, we return the sub here. Okay. Okay, so we return the it's mount. We return the multiply here, and if it's divide, return the divide here. Finally, it's the exponential, so we return here. This is none here. Okay. So come here. When we come here, we just panic. Should not come to here, right? Okay. So just panic here. Okay, let's define the creator function for the point. So we have from here. Now we say a new elliptic curve point. Okay, here elliptic. Yeah. So we have its x here, or it should be in y a and b. Then finally we return the pointer of the point here. Okay, return the pointer of point here. So we first we need to check whether giving the point x y here, we need to check whether it's on the curve or not. So we should compute the left side and the right side, and then check the left side is equal to the right side. So we need to make sure the point is on the curve. So here we have a left here up on B, right? So here is x, y with its power of 2. So we have b new in. So it's with its power of 2 here. Here we have it. So we do this operation here. Now let's see the x power of 3. Now let's do the x power of 3. So we do the x power of 3. Okay, so this is the left side. Now we compute the right side. The right side, the first term of the right side is the x to the power of 3. Now a multiply x, so it should be up on b. So this is the a x and mul, right? Now finally we have the y here should be up on b. So we need to add these two. We need to add these two, right? So we have up on bit here is x3 and ax, and this is add. Now finally we add to the b, right? Now this is operation for add. Okay. So we need to compare the left and the right. They should be equal, otherwise the point will not on the curve. If they are equal, the point will on the curve. So we have left compare right. If this is not equal to 0, which is error here, so we need to get the error. We need format a string point and point. We have v is not on the curve with a here a and b. Now here we give the we should give a return here. Now we can put the x, y, a, and b here. Now we just panic here. Okay, so we just panic. Otherwise, we will return the point. We will use the point object and return its pointer to the column. So here with a is a, right? B is b. Actually, we should put the x here and y here, right? This is all our new creator function. Okay, let's save the file here. So you can post the video. Please post the video and make sure you type in the code as I have done here. Okay, post the video, type in the code, and post the video, type in the code here, and post the video and type in the code here. Make sure you type in the code. Now let's add two more helper function here. So we need to two more help function. So let's see how we can check whether 2 points are equal or not. So here is the point here, and we return the bool value. So if 2 points are equal, then all the components of the point should be equal. So we need to check. So we need to check all the component here, and all the component here should be equal, and the component x should be equal. Other, this is x, and this y should be equal. Right? Oh, this should be 0. If they are all equal, then we'll return true here. Otherwise, we'll return false here. Okay. So yeah, let's see what's the error here. So oh, we need here. Yeah. Okay, here. So we should that's what if we need to check 2 points are equal or no, we need to check their components are all equal. So let's see how we can we can do the not equal. So let's see not equal. Okay, this is a question for you, a practice for you. How can you do this function? How can you return the not equal? How can you check the 2 points are not equal or not? So do you know how to do this? How to write a code here? So please you can pause the video and do your code here. Okay, I guess you have finished your code here and let's see how we do it. So if it's a not equal, only for any one of the component is not equal, right? So we can make it here. We just make a all here. So let's see. Let's make a all here. It's not equal here. Oh no. Okay, let's see. It's not equal, right? Now this change to all, or not equal, and this change to all, and these are not equal, and this change to all. Here this is not equal, right? Then we return true. So any one of the component is not equal, then these 2 points are not equal. Otherwise, they are equal. So we return false here. Okay, that's all from our. And in next video, let's see how we can call the code here. So make sure you are input the same code here. And in next video, we will check how we can run the code here. I will see you in next video. Bye bye.